Echoes from the Eons, Episode 4, Beasts Between Time, produced by the National Dinosaur Museum, Canberra. There is a weird place in time, between the end of the Mesozoic and the beginnings of human history, that is so often overlooked in the public mind. This forgotten space saw the rise of mammals as a dominant class, and was an age of huge beasts and tremendous environmental upheaval. It has a far more accessible fossil record than the romanticized world of dinosaurs and trilobites. Yet, aside from a brief nod to the Ice Age, itself something of a misnomer, as our planet has endured several, it is an era glossed over. It is important to remember that there are 66 million years between the end of the Mesozoic and the beginning of recorded human history around 5,000 years ago. Within this great spectrum of time, we would see the rise and fall of many outlandish creatures in habitats that often do not correspond with their regions today. The world is in a constant state of movement and change, and this has an effect on the types of life in each area, their chances of long-term success, and our chances of finding evidence about them later. The frigid wastelands of Siberia and the great impenetrable tundra of the Northeast Asia are a ready example of these changes. It is here some of our most famous animals from the Cenozoic prehistory are found. The vast plains of snow, ice, glacier, and permafrost are filled with well-preserved treasures, frozen in time and place. There would be few people who are unfamiliar with the notion of a mammoth. That the name takes a place in regular vernacular to describe size is testament to its widespread fame. The word mammoth, while commonplace now, has an unclear origin, potentially coming from Vogel, a Russian ethnic minority, Estonian or Arabic, but the first recording of its use in Europe was in the 17th century. Woolly mammoths, their larger cousin stegodon, and the smaller woolly rhino are all examples of the types of specimens pulled from the frozen Siberian landscape. Mammoth teeth and tusks discovered in Europe had variously been attributed to biblical giants, or remnants of war animals introduced during Roman times, and were not properly studied or identified as woolly mammoth until 1728 by Irishman Hans Sloane, who considered them to be some kind of modern elephant transported to the Arctic, perhaps in the Great Flood. It wasn't until later, in the 1970s, that it was suggested by French anatomist Georges Cuvier that these were not modern bones, but a new species altogether, and, more controversially, one that was now extinct. There are many remains of different species of mammoth that have been found across different locations, and this allows a fairly comprehensive morphological study of the genus to take place. A mammoth species is identifiable by their teeth, a body part which when fossilized can produce particularly beautiful blue, grey and yellow striped bands. These bands represent the enamel ridges on their molars, the number of which was few in more primitive species and increasingly dense in later species. This increase in ridges most likely reflects a move towards a diet containing more abrasive foodstuffs. Not only did the teeth develop more of these ridges, but they became deeper in height, the skulls also growing taller to accommodate them. The dentition and tusk arrangement of different types of prehistoric elephants are not all so straightforward. Gomphotheres, for example, a much older Pleistocene relative of a different branch of the Elephantida group, supported not 2 tusks, but 4, and the ambulodonts also sported a lower set of tusk-like features, but these were flattened and almost scoop-shaped. We are fortunate with mammoths that we have some excellent preserved evidence, but as their existence overlaps at a time with early humans, we are also lucky to have recorded evidence. Cave paintings, such as those found in the impressive French Rouffignac cave, depict these and other animals in great detail, showing features that may not be immediately clear from isolated specimens. Rouffignac, La Grotte aux Saint Mammoths, or the Cave of 100 Mammoths, contains over 250 engravings and cave paintings that go back to the Upper Paleolithic. It belongs to an impressive cave system of over 8 kilometers of underground passage and contains, amongst an unparalleled amount of mammoth art, works depicting rhinos, bison, ibex, a type of goat, horses, and more. Of the many mammoth specimens available, the best preserved is a near-perfect little juvenile named Lyuba. Lyuba, an affectionate diminutive in Russian for love, was uncovered in the Yamal Peninsula in Siberia in 2007 by reindeer herdsman Yuri Khudi and his sons. Suffering some minor damage before being turned over to the Shemenovsky Museum and Exhibition Center in Salakhard, Lyuba's impressively well-preserved body even included her stomach contents, revealing milk and twice-digested plant material. She is estimated to be around 35 days old at the time of her death. Close examination of her milk tusks show that she was born in spring and had enjoyed a healthy and well-fed existence up until her rather abrupt demise, which most likely involved her drowning in mud. The layers of growth on a mammoth's tusk are a good indicator of their health and age, as these continue to grow throughout their entire life cycle. The deep cold of the Siberian landscape is not the only reason her body was found so intact, and there is evidence that the mud mixture she fell into appears to have pickled her, effectively guarding against further rot. There are 10 different species of mammoth, and they are not all the shaggy giants one tends to think of. Mammoth Saxilis is a pygmy mammoth from the Americas, and its diminutive size is attributed to a phenomenon known as insular dwarfism. These mammoths inhabited islands, and so their environment was small and restrictive. Their gradual reduction in size means that their bodies required less food and energy to survive, and allows them to be more successful in this smaller environment. Interestingly, the reverse effect can also occur, a process referred to as insular gigantism, which can still be seen today in the case of the Madagascan fossa, a relative of the smaller continental mongoose. Mammoth criticus, found on the island of Crete, is another type of dwarf mammoth, and the smallest to have ever existed, with an estimated shoulder height of only a meter. The islands of the Mediterranean and Greece were populated at various times by many different kinds of Elephantida. The pygmy elephants on the Greek island of Rhodes endured until as recently as 4,000 years ago. Likewise, other archipelagos enjoyed their own variants of long-trunked and tusked fauna. The Indonesian islands of Sulawesi, Java, and Flores are just a small selection of these. Here, between the Miocene and Pleistocene, populations of stegodonts lived, likely swimming between the different islands as no land bridges were in existence. Stegodonts are typically a little larger than their mammoth equivalents, but they too could be subject to insular dwarfism, as seen in the species found on the Isle of Flores, with a shoulder height of about 2 meters. One of the interesting things about this stegodon is the fact that it coexisted with a small homonym, or human-like relative. Although Homo floresiensis is also quite small, it has been nicknamed the Hobbit, it does not appear to be that way due to insular dwarfism like the stegodons it likely would have hunted, but was already small on its arrival in the area. Between the icy plains of Siberia and the humid islands of Indonesia, on the Asian continent proper, there once existed another fabulous creature of immense size and power. Standing about 3 meters tall and weighing a whopping 500 kilograms, Gigantopithecus was the largest ever known ape and an early relative of humankind. Inhabited what is now South China during the Pleistocene. While this massive animal would have been a looming giant when standing on 2 legs, it's likely that it would have spent most of its time getting around on all 4 limbs. This can be concluded partly from comparisons of its teeth and jawbones with orangutans, which were also primarily quadrupedal, and by considering the physical challenges of supporting such a massive amount of weight on only 2 legs. When the first tooth was discovered in 1935, sitting for sale in a Chinese drugstore in Hong Kong, marketed as dragon bone, it was mistaken for the tooth of an especially large human. Although not a human, indeed it is closer related to the Pongo genus, which includes the modern-day orangutan, it has been found alongside other hominids, such as Homo erectus. The fossil record for Jacantopithecus is nowhere near as generous as that of mammoths, which had the advantage of both the cold environment and comparative recentness on their side. Instead, this giant ape is known from a large collection of teeth and 4 partial jawbones. The regions in which these fossils have been found are tropical environments. Such pervasive moisture and heat are not favorable to optimal preservation. During the Pleistocene, between 2 million years and 300,000 years ago, their world would have been one of monsoonal forest, birchy oak-type trees and ferns, and can be expected to have been populated with large numbers of predators and competing fauna, and this could be a contributing factor to its incredible size. The humid Chinese environment has effectively erased the possibility of extracting usable DNA to help determine potential lineages, as ancient DNA degrades quickly, and under such circumstances, it would not likely survive past 10,000 years. It is possible now, though, through paleoproteomics, the analysis of ancient proteins, that can be sequenced in a way similar to DNA, to help determine how closely it is related to other species, and thereby assess its evolutionary journey. These proteins can last millions of years, and while they are not as detailed as a full genome, they can be extremely informative. Paleoproteomic study may look at collagen, a single protein found in bones and other tissues, or the multiple proteins found in tooth enamel. A Gigantopithecus molar, found in Choifeng Cave, China, is the oldest dental enamel to be sequenced, at an incredible 1.9 million years old. Travelling further south, to the Australian continent, where the contemporary flora and fauna are unique and unfamiliar to most of the rest of the world, we are introduced to some of those unusual animals' oversized ancestors. Two of the largest remaining birds on Earth are found in Australia. The cassowary, an aggressive blue-necked flightless bird around 1.7 metres tall, and the more amicable, less colourful emu around the same size. But there was once a time where these would be considered small. Mihirungs, or Dromaeornithidae, are a group of large and flightless birds related to geese that existed across the Oligocene and Pleistocene. The largest of these was Dromaeosteotone, a late Miocene creature that was over 3 metres tall and weighed half a ton. It has only been recorded at one site so far, the Alcuda Station in the Northern Territory. Alcuda is an exceptionally rich fossil site stretching out over 200 metres and comprised of over 300,000 individual animals. One of the last remaining Mihirung was Geornis newtoni, a little taller than an emu, but more than 4 times its weight. Originally, 3 skeletons were found in 1894 near the South Australian Lake Callabonna, and since then bones, footprints, and even egg remnants have been uncovered. It's worthwhile to note that these would be no common eggs, likely weighing over a kilo in their complete form. Although these great birds were of an intimidating size and had sizable, powerful beaks, it is likely that they were herbivorous animals. There are several arguments that point towards this. Comparing such a large beak with other fruit and leaf-eating birds such as toucans, it can be seen that a powerful beak has more potential than just killing. Many of the skeletons have been found with small amounts of stones around their gizzard area, suspected to be gastroliths, that is, consume stones that assist in the digestive process by further grinding food. An analysis of eggshell not only returns evidence for consumption of plant matter, but also points towards a higher consumption of leafy greens rather than grasses. There is also a matter of anatomical proportion. Emus, cassowaries, and ostriches, the largest birds today, fall into the category of birds known as ratites. Mihirungs, much like the geese and ducks they are related to, fall into the category of aves, and as such have a proportionally larger head compared with their overall body size than that of a ratite. For all this, however, they were not the largest of all Australasian birds. The New Zealand Moa, also a herbivore, was the largest terrestrial animal on the islands until the arrival of the Māori people. The moa was a flightless bird like the others, but it lacked even the stumpy vestigial wings of its cousins. Falling into an order known as Dinornithiformes, the moa could range from around turkey size at the smallest to the South Island giant, over 3.6 metres tall. Arguably the most iconic of all Australian animals, the kangaroo, was not without its own supersized predecessor. Modern-day kangaroos come in a range of species, from the abundantly common eastern grey to the largest of all marsupials, the red kangaroo. Pushing 2 metres in height and 90 kilos, an adult red kangaroo is something to be very wary of. But the Stenurines of ages past was something altogether different. These were short-faced kangaroos, with forward-facing eyes, shorter, deeper skulls, and although they had powerful legs, they were likely not suited for high speed over long distances, as our modern equivalents are. Their feet were formed into a single large toe with a hoof-like nail that would have gifted them with powerful bursts of acceleration and speed, but these would not have been for extended periods of time. They also would not have had the same hopping sense of locomotion that we associate with kangaroos. Part of the reason for this is their size. The largest of the short-faced kangaroos was the Procoptodon goliah, at 2.6 metres tall, and 230 kilos. And at such a cumbersome weight, the risk of snapping tendons during a hop-type motion is greatly increased. Instead, they probably walked. In addition to their standing height, this Procoptodon also enjoyed long and mobile arms, complete with 2 middle fingers fitted with long recurved claws. This allowed them to be perfectly suited to browsing in the semi-arid areas of New South Wales and South Australia that they are found to inhabit. The foliage it consumed was probably quite rough and abrasive, as indicated by the large number of fine ridges that can be found on its heavily enamelled teeth. As with the cave drawings in France of earlier human interactions with mammoths, there does appear to have been some contact between Sthenurines and Indigenous Australians. Among some of the ancient rock art, there are kangaroo forms and kangaroo tracks showing that one big toe. In Western Australia, a Sthenurine leg bone has been found with a notch that seems to have been made with a tool, and there are multiple other sites where bones have been found charred or smashed, suggesting that they have been cooked and consumed by humans. These animals are just the barest glimpse of life between the fall of dinosaurs and the rise of man. Continents shifted, rivers were formed and dried up, and there were periods of great drought, of fire, floods, and ice, and at each corner of the constantly shifting world, something wonderful was going about its day. Many of those will never be known to us, their bodies not striking lucky in the great lottery of preservation, and even those that do leave behind remains will stay cloaked in mystery, no matter how well we can assemble the pieces of their puzzle. It is something worth thinking about and remembering, the ethereal nature of life and the certainty of change. What do we leave behind, and what will the future masters of our planet look like after the age of man is done? The National Dinosaur Museum hopes that you've enjoyed this episode of Echoes from the Eons, supported by the ACT government through the Where You Are Festival 2020, produced by Events ACT. This episode has been written by the National Dinosaur Museum, with thanks to Kieran Bourne, Bella Shaw and Mitchell Seymour, and has been voiced by Samantha Chester. Check out our website or follow us on Facebook for more great content, or better yet, come visit us at the museum.